Hello, this is Mrs. Myers, and we are going to be learning some coordinate geometry today. And we're going to be talking about parallel and perpendicular lines and how that relates to the slope in a coordinate plane when you've graphed a line or when you have the equation of a line. So you can see here I have this parallel symbol. All of these bullet points here are about the parallel lines. And down here I have the perpendicular symbol, and all of these bullet points here are about perpendicular lines. So starting with the parallel lines. If two lines are parallel, then they have equal slopes, or the same slope. So if one line has a slope of 3, and there's a line parallel to it, it also has a slope of 3. The converse is also true, meaning if you have two lines and you know their slopes, let's say the slope of this is nope, that doesn't look like a fractional slope. Let's call it a slope of 2, and this has a slope of 2, then you can conclude the lines are parallel. So remember, converse just means you're flipping the if and the then. So if two lines are parallel, then they have the same slopes. Converse would be if same slopes, then parallel. Okay? If two lines have, oh, here it is. Here's the converse right here. Didn't have to write that one out. If two lines have equal slopes, then they are parallel. That's the converse. Any two vertical lines are parallel. We're looking at this one here now. Any two vertical lines are parallel. All right, well, if you've got this vertical line and this vertical line, they're going to be parallel, and they both have a slope that is undefined. Similarly, any two horizontal lines are parallel, and they both have a slope of 0. Okay, we learned this when we talked about the equations of lines and graphing them, etc. Remember, a vertical line has the equation would look like this, like y, oops, sorry, vertical is first here, x equals 4 would be a line where it's a vertical line going through 4, right? Vertical line, x equals 4. And a horizontal line, the equation would be in the form of y equals something. Let's say y equals -2. Here's the coordinate plane. Y equals -2 would be this horizontal line here. Okay? So, given two lines where one line passes through the points 1, 3 and -3, -5, the other passes through the points 5, 4 and 2, -2, determine if the lines are parallel. Okay, so we've learned the slope formula already. The slope equals y2 minus y1 over x2 minus x1. So if we do that for both of these sets of points, that one and this one, we can find the slope of each line and then compare them. So let's do this one. y2 minus y1 would be -5 minus 3 over x2 is -3 minus 1. That's -8 over -4, which is a +2. Slope formula for this one, y2 is -2 minus 4 over x2 is 2 minus 5. You've got -6 over a -3, and that's a +2. So, since they both come out to 2, same slope, or equal slopes, therefore, they are parallel. Okay? Write the equation in slope-intercept form of a line that's parallel to this line and contains the point -2, -2. All right, well, when we are given a point like this, that's an x and a y, right? There are two ways that we can do this. We have learned slope-intercept form, y equals mx plus b, and we've learned point-slope form. Which is sorry, it's actually just x minus x1 and y minus y1. Okay, so that's point-slope form. So when we see a phrase that says, that is parallel to, or that is perpendicular to, eventually we're going to learn, but when you have a phrase that says either parallel or perpendicular, and then it gives an equation, all you want to use that phrase for, and that equation for, is to identify the slope. So this whole phrase, you just want to use it for one fact. Slope equals. And in this case, y equals 4x minus 2, we should be able to see that the slope is 4. So you're just going to use that phrase for the fact that the slope is 4. That's it. That's all you're going to take from that. After you decide the slope is 4, you completely don't need this equation anymore at all. Okay? You are going to write an equation that contains this point. So like I said, there's two ways to do this. You could use point-slope form and then just turn it into y-intercept form, which I think is the easiest way. So if we have a point and we have a slope, we can use point-slope. So what we're going to do is we're going to say y minus, and then we use the y that we're given here, and that's -2, equals, m is the slope, 4, times, x is also -2, so we're going to do x minus a -2. So when we plug into point-slope form, remember minus the negative is like plus a positive, plus a positive. What do we have? We've got y plus 2 equals 4 times x plus 2. Distribute. Subtract the 2 from both sides because we want slope-intercept form they're asking us for, right? So we get y equals 4x plus 6. And that's our final answer. Okay, so if you have a slope and you have a point, that is where the point-slope form comes in handy. You stick in the slope where this m goes, and you stick in the point x, y, -2, -2 goes in for the x and the y of the formula. Okay, so now talking about perpendicular lines. When lines are perpendicular, they have opposite reciprocal slopes. In other words, when you multiply the two slopes together, you'll get -1. So in other words, we have, let's say, a slope of 2, for example. The perpendicular slope to that would be opposite, meaning change the sign, and reciprocal, meaning flip it upside down. So if we have a slope of 2 and we want the opposite reciprocal of 2, we're going to change the sign, make it negative, and flip it upside down. Well, 2 is like 2 over 1, right? Anything can be put over 1. So the opposite reciprocal would be -1/2. Flipping 2 over 1 upside down gets you -1/2. Okay, so another example, a slope of 3/4 would give you a perpendicular slope of -4/3. Change the sign and flip it upside down. Okay? Okay, so if two lines are perpendicular, they have opposite reciprocal slopes. If two lines have opposite reciprocal slopes, then they're perpendicular. So the converse is also true in this case. The last thing here, every vertical line is perpendicular to every horizontal line. If you draw a vertical line straight up and down and a horizontal line left to right, they're always going to be perpendicular to each other. Okay, so given a line that has a slope of 6, what is the slope of a line perpendicular to it? You guys try that. If the slope of the original line is 6, you want the opposite reciprocal of 6. Fill that in. Okay, did you do it? You should have gotten -1/6. Number 4, given a line that has a slope of -2/3, what is the slope of the line perpendicular to it? Again, you want the opposite reciprocal of -2/3. Fill it in on your own. You should have gotten +3/2. 3/2. Okay, write the equation in slope-intercept form of a line that is perpendicular to that equation and contains this point. Again, just like I said up with the parallel lines, this phrase is only used for one reason. You don't need the whole equation. You just need to look at the equation and decide what the slope is. Well, the slope of this equation is 3. The slope that's perpendicular to that would be the opposite reciprocal of 3. So we're looking at a slope of -1/3. Like I said, once you use that phrase to determine what the slope is, you don't need it anymore. You're just going to use it for that one fact. Okay, slope is -1/3. That's what we're using. And the point is 6/2. Again, even though they're asking us for slope-intercept form, I would start with point-slope form. You've got y minus y1 equals m times x minus x1. So you're going to do, remember this is x, y, x1, y1. So you're going to do y minus y1 is 2, right here. And the slope m is -1/3, x minus, and then x1 over here is 6. Y minus 2 equals -1/3 x plus, right, you're distributing, -1/3 times a -6 is a +6/3, which is just 2. So y equals, y minus 2, I'll not change that yet, equals -1/3 x plus 2. 6/3 is just 2. Now we're going to add 2 to both sides. And we get y equals -1/3 x plus 4. That is the equation of the line. Okay? So there's a few things that we can practice here. Are the lines shown in the graph perpendicular? And explain. What you want to do is find the slope of each line. So the slope of the line that contains these 2 points, right? You've got -2, 5 as one point, and 1, -4 as the other point. The slope formula, again, y2 minus y1 over x2 minus x1. So you're going to do slope equals -4 minus 5 over 1 minus a -2 And that's negative 9 over 3, which is negative 3. So that's the slope of this blue line here. Now let's do the green line. The green line has the points negative 4, 1, and 2, 4. Here's negative 4, 1, and here's 2, 4. So you want to use the slope formula again on that one. I'm going to let you do that one on your own. Number 7, and then once you get both slopes, you decide if they're perpendicular. Number 7, what is an equation for a line perpendicular to the one shown that contains 0.5, negative 1? Okay, so first thing you want to do is find the slope of the line shown. Well, you have the 2 points, 2, 3, and negative 2, negative 7. So again, you're going to use the slope formula. y2 minus y1, x2 minus x1. You're going to use that there. Then, once you have the slope of the line shown, you need to figure out the slope of the line that would be perpendicular to it. So take the opposite reciprocal. Then you're going to write your new equation using, again, point-slope form is the best way to do that. All right, and number 8, the baseball field below is on a coordinate grid with home plate at the origin. A batter hits a ground ball along the line shown. The player at 110, 70, this guy right here, runs along a path perpendicular to the path of the baseball. What is the equation of the line on which the player runs? So, in other words, here's the path of the baseball. You want a line that's perpendicular to that and contains this point. So, this is going to walk you through those steps, and you should see how you do on that. You should do that on your own and then come back and check your answers. Okay, so if you check your answers here, the slope of the two in number 6 do not turn out to be opposite reciprocals, so that's not perpendicular. Number 7, the slope of the line shown is 5/2, so the perpendicular would be negative 2/5. Plug that into point slope form. You end up with y equals negative 2/5 x plus 1. And number 8, the slope of the baseball path is 1/3, so the slope of the perpendicular path is negative 3, opposite reciprocal. Again, plug it into point slope form and solve for your equation. Okay, thank you.